Hey guys, this is my free lesson on rational expressions. Specifically, we're going to talk about evaluating and working with domains of these expressions. And just as a reminder, guided notes are available for free to accompany this lesson. So let's get started. So first things first, just where can fractions have a zero? So if you think about what a fraction looks like, so let's say I have this thing a over b, a lot of people forget this. Where can this actually have a zero? So here, this would be a 0 is okay. Here, this would be 0 is not okay. What happens here is that this would make the expression undefined, and so that's something that we really care about when we talk about rational expressions. So this is true for fractions, and it's also going to be true for rational expressions. So that begs the question then, what must we be concerned about with rational expressions? So if I have just any rational expression, I have to be worried about when the denominator is equal to 0. So we have to worry about the denominator equaling 0. So for these three examples, what I want you to do is evaluate each of these rational expressions for x equals 2. And to do that, it's exactly what you'd probably expect. So basically, wherever you see an x, you're going to replace it with a 2. So by doing these three examples, this is going to kind of illuminate kind of the greater point that I'm trying to make. So go ahead and pause the video and work these out, and then we'll go through these together. So starting with a, the first thing that I'm going to do is I'm going to replace each x with the 2 as shown. So let me work that out. So I've plugged in my x, and now I just need to go ahead and work this out. And so if I go ahead and add all this together, I'm going to get 16 plus 8 over 20 plus 15. Notice I can do all of this without a calculator, so this is going to be 24 over 35. So you definitely should try to do stuff like this without a calculator. It's just going to make you a little more confident when you're working with the numbers. So I know it takes a little bit longer, but it's definitely worth the investment. And so as far as this one goes, so this answer, this is perfectly fine. This is all that we're looking for. There's nothing to simplify, so we can just move on. Okay, so let's do that again now for b. So I'm going to go ahead and plug in 2. And I'll keep simplifying from here. And so if I keep going, so now you're going to see that I get 42 over 0. And so this is kind of the point that I'm trying to make with this particular lesson. So this is a problem. So you can't just leave your answer like this. You want to actually interpret this. That would be kind of the most thorough thing to do. So the final answer here then is going to be, this expression is undefined. So you want to make sure that you're thorough about that. This expression won't equal 0. You're not allowed to have a 0 in the denominator, so this will equal something undefined. Okay, so let's do this one more time. Again, using x equals 2 for this. I'm going to go ahead and plug that in. And I'll continue to work this out. Okay, and so now for this one, I have a 0 in the denominator. So remember, we said it's okay to have a 0 in the denominator, in the numerator. So we have a 0 on top. Maybe I'll just say that instead. And so then I just want to, once again, interpret this entire result. So when you have a 0 in the top, that means that the entire expression just equals 0. So it cancels out all that work that we did in the bottom. So to summarize, with rational expressions, when a rational expression has a 0 in the numerator, what does this actually mean? Well, it means then that the value of the expression is going to equal 0. And when a rational expression has a 0 in the denominator, what does this mean? So if you have a 0 in the denominator, that means that the value of the expression is undefined. So that is a very important distinction to make with rational expressions that we're going to explore a little more. But one other thing I want to add on to this is the concept of a domain. So I'm going to give you a really informal definition for this. If we're just thinking kind of informally about what the domain means, so I should probably write informal here. I think some some math people might get kind of mad at me for this definition, but I'm going to go ahead and state it anyways. So you can think of the domain as what the independent values or x values are allowed to be. So we can think about this as what the independent or x values are allowed to be in the expression. So basically what we're worried about then is we want to just always exclude any values that would make the expression undefined. So if we know how to do that, then we really know how to find the domain. Now, a lot of times when you're talking about the domain, you want to actually, when you're talking about the domain of a rational expression, really what you're looking for then is, once again, so where would a rational expression be undefined? Well, this would happen when the denominator equals 0. So, what are we concerned with for the domain of the rational expressions? So we are concerned with values that make the denominator 0, and so what we want to do is exclude these values from the domain. Now the way that we do this is using what's known as interval notation, which sometimes people know this or maybe they forgot it. So what I want to do is just take a second to give you a little lesson on what interval notation is. So interval notation looks like So here are 3 examples of just what interval notation actually looks like. So just to kind of help you understand what this means. So the first number is always telling you a starting point, and then the second number is always telling you an ending point. Additionally, what these brackets at the end here mean, so these have actually their own meaning. So brackets that use like this square bracket, so this means the number is included. Or if you're talking about this in terms of using like inequalities, which is where we usually use interval notation, this usually is used for the less than or equal to sign or the greater than or equal to sign, because that would kind of tell you that the number or the endpoint is included. The other signs that we use are these rounded brackets. And so what this means is that the number is not included, or we use it for infinity. Alternatively, this is also used for the less than or greater than sign. So this is kind of a shortcut. The big thing that you want to know here is kind of what these symbols stand for. And then again, when you read this, so this is talking about where you start and where you end, and this would mean that you start at 2. For this expression here, this would mean that you would come as close to 5 as possible without ever touching 5. Now, infinity, when you use infinity with interval notation, infinity is not an actual physical number. It's not a number, so it always gets a rounded bracket. That's why infinity always gets that. And then with an expression like this, so what this would tell you is, so this is talking about that you start all the way from the beginning of the negative numbers at the concept of negative infinity all the way up to 3. And then you stop at 3, and then you pick this back up at 5 and continue on to infinity. So this is just kind of some examples of what interval notation could look like. So now what I want to do is just give you a second to practice this. So let me just show you a few examples of how to write these expressions with interval notation. So when you're getting used to this, sometimes it can be helpful to draw a number line to go along with this. So maybe just one other thing to note with a number line. In general, so for terminology, with number lines, we use these symbols for the less than or greater than sign, or to show that a number is not included. And then for the other signs that we use for number lines look like this. And so this is for less than or equal to or greater than or equal to. So this would mean that the number is included. So notice that this notation, this is very similar. So some books will use the open circle and the closed circle. Other books will use the brackets. Personally, I prefer the brackets, but if you like using the dots, that's totally fine. I like using the brackets because it's the same thing that you use for interval notation, so it's one less thing to remember. Okay, so if I come back here, so if I want to think about these in terms of a number line, let's think about this for this first example, x is greater than 3. So if I wanted to represent what that looks like on the number line, so let's just draw a little picture here, and then this will help me figure out what the interval notation is. So I need to figure out where is x greater than 3. So here's 3 on the number line. So am I going to be on the left or on the right to get to all numbers that are greater than 3? Well, all numbers over here are what's greater than 3, so I can go ahead and just color this. But the last thing that I need to know is, do I actually include 3 in this set? So I do not include 3. Another way you could think about this is, so this little cheat that I've written here, so this is using a greater than sign, so that's going to use one of these round brackets. So I'm going to use a round bracket here. Like I said, if you like using dots, alternatively, you could have an open dot here. That's totally fine. In general, you want your bracket opening in the direction of kind of where you've colored. Okay, so here's kind of a picture of what's going on. So this is going to help me figure out what my interval notation is. So my interval notation is going to start at 3, but it's not going to include 3 because 3 is not included in x is greater than 3. It has to be all numbers directly above 3. So I start at 3 and then I continue on this direction. So this direction this way, this is the positive infinity direction. And just for reference, this direction going that way, that would of course be the negative infinity direction. So this kind of helps me then to figure out what my interval notation is. So like I said, we start at 3, but we don't include 3, so we use a round bracket. And then we just continue all the way on to infinity. And infinity always gets a round bracket, so that would be it for this one. Okay, so maybe what you want to do is try pausing the video and trying this next one. And you could also try making a number line that would explain how to do this one. So maybe pause the video and see if you can do these other two. Okay, so if I just wanted to draw a little number line representation of this situation, so here's -5. So which direction do I have to go now to be less than -5? Well, all the values over here are getting smaller than -5, so this is the direction that I want to go. And once again, so I'm going to actually use the rounded bracket or the open circle, whichever you like. But now what I want to do is I want to describe my interval notation. So with interval notation, you always want to think about this as if it were a book. So you want to read it from left to right. So I start here on the left and then I continue my way on the right. So if I'm starting all the way on the left here, well, this is all already colored. So what that's indicating to me is I'm actually starting at negative infinity. So this is negative infinity, and then I go all the way to -5, and I use a round bracket for each. Okay, so what about, how would I represent this idea in interval notation? Well, here I've got 1 and 3 on my number line. And so what I want to do is I want to draw my number line in a way to show that I'm excluding these two. Well, if you think about what I told you with number line notation, so the open circle or the rounded brackets, that's what indicates that something is not included. I guess for this one, this would actually probably make the most sense to use the open circle. So let me just draw these nice big open circles. So that would indicate to me that 1 and 3 are not included, but I want to include literally everything else on this number line. So I need to write some interval notation that would represent this situation here. So again, we're thinking about this as a book from left to right. So if I start here on the left, I'm starting at negative infinity, and I'm continuing all the way to 1, but I'm not including 1, so I use that rounded bracket. Then what I want to do is I want to continue this now from 1 to 3. So what you do when you need to make a jump is you actually use the union symbol, and then you can just continue. So now I need to go from 1 to 3, and then I need to jump over 3, and I go from 3 to infinity. So this would be the entire answer. So a lot of times having the picture in front of you is very helpful for figuring out what your interval notation needs to be. So why are we talking about all of this? This is actually going to come in handy with kind of the next exercise that we need to do. So in the next examples, I want to use the same questions over and over. So this is actually a 3-part question. The first question is, where does the expression equal 0? The next question is, where is the expression undefined? And then the last one is, what is the domain of the expression? And we want to state that in interval notation. So we'll actually state this two ways. We'll state it in plain language, and then we'll also state it in interval notation. So these are three related and key questions that have to do with rational expressions. And these are kind of finer points, but they're usually very important ones. So let's do this first example together. So first question, like we said, where does this expression equal 0? So you have to think about everything that we've talked about up to this point. Maybe you even want to review your notes for a second. For a rational expression to equal 0, what has to be true? Well, the top has to equal 0. So maybe I'll do this first question all in blue so I can just kind of have my notes color-coded so that you can kind of follow them. So for question 1, so we need to know, where does this equal 0? So that's informally what we're interested in. So how do I figure that out? Well, you might be able to just look at it and figure it out, but if we want to be maybe a little more formal about it, what I'd want to do is just set the top equal to 0. So I could solve this equation here. If I know where the top equals 0, then I have my answer. So I can just solve this. This is just like your regular old, algebraic expression. So I can go ahead and subtract 3 from each side. I get x equals -3. So this would actually be my answer. So if we want to actually write this out, I'd say the expression is 0 when x equals -3. Okay, so that's the first question, right? So now let's move on to the next question, which was, where is this expression undefined? So I will do kind of everything for that in pink here. So if I want to know where this expression is undefined, what am I really looking for? Well, that's the same as asking, where does the bottom equal 0, right? So let's just note that. If I know that, then I know for sure where the expression is undefined. So it's actually going to be the same idea. I'm going to take the bottom and set it equal to 0, and then once again I can solve. Now you might be able to look at this and just eyeball it, but I'll go ahead and just be nice and thorough. So this will equal 0 when x equals +5. So let's just write that out. So you want to keep these two things straight. Where is the expression 0 versus where is the expression undefined? If you know where the expression is undefined, then you know how to find the domain. So now the domain is going to be our third part here. And the domain is really related to this answer here. So the domain is going to be all numbers except x equals 5. That would be the technical domain. So again, if you just want a reminder of what does it actually mean to be the domain? So the domain is what the independent values are allowed to be. That's really what we're stating when we say the domain. So if I come back to this question here, what is the domain of this? It's any number except for 5. That's what the domain actually is. Now I have to represent this in interval notation, and that's where drawing a number line could actually be helpful. So if I think about this, I want to show all numbers except for 5. So very similar to what we did before, right? I really need an open circle at 5, and otherwise these would be all of the numbers that we're allowed to have for the domain. So I can plug in anything I want into this as long as it's not 5. At 5, this is not defined, but any other number would give me an answer. So now I just have to write this out in interval notation. So if I do that, that's going to be -infinity to 5 with a round bracket, and then 5 to +infinity. And so that would answer the 3 questions for this particular problem. Okay, so now let's take a look at another one. Different, but still a similar idea. So maybe what you want to do here is just pause and see if you can figure out parts 1 and 2, and then maybe hit play just to make sure you've got that part. So for the first part, so again, if I use that color coding, so where does this expression equal 0? So I'm going to take 2x plus 1 and I'm going to set it equal to 0, and then I'll just solve for x. So let's go ahead and just go through the motions of solving for this. So I get the answer that x would have to equal -1. So what that means is if I plug -1 in, that will give me a 0 on the top. So let's just write out what that means. So writing out these sentences is really helpful to get your brain to kind of understand what you're doing. Not all of math is going to be just straight numbers. A lot of times, if you really want to understand math, you want to use your words. So you'll notice a lot of times I actually write out sentences, and it's because it helps my brain to get what I actually mean. That's kind of a really important skill that I think is a little bit underrated a lot of times in math classes. Okay, so let's go ahead and try the next part of this. So where is this undefined? So once again, what I'm going to do is I'm going to take x squared plus 7x plus 10, and I'm going to set this equal to, oops, not 10, I'm going to set it equal to 0. How would I solve this in this case? Well, to solve this, what I need to do is I actually just need to factor this. So this factors x plus 2 times x plus 5. And then if you forgot how to actually solve something like this, so what you want to do is set each, so when you have multiple factors, if multiplying these together equals 0, that means that you set this factor equal to 0 or this factor equal to 0. So you have to just set each one equal to 0. So what I want to know is, when does x plus 2 equal 0? Well, that would happen when x equals -2. And then when does x plus 5 equal 0? That happens when x equals -5. And you can go through the algebra to solve that on your own if you wish. So now for this problem, there are actually two values that would cause this expression to be undefined. So let's just write that out. And I'm running out of room here. But so when we say when x equals -2 or x equals -5, the expression itself will be undefined. Okay, so now I have everything that I need then to figure out the domain. So maybe I'll just give myself a little extra space up here. So the domain, in plain words, the domain is all real numbers. So what that means, all real numbers, that's referring to really any number that we can plug in. Any number I can plug in except x equals -2 or x equals -5. So those are the two numbers that we want to exclude. So what I'm saying here is the domain is anything I want as long as it's not -2 or -5. At those two values, I know that this expression will be undefined. So now I just have to represent that on a number line. So here's -2, here's -5. And so now I just want to color the entire number line. And I just want to show in my interval notation that those are the two values I'm excluding. So that's going to be -∞ to -2, unioned with -2 to -5. Oops, I just realized that I can't do math today. All right, sorry about that. Sorry, I totally flopped up my number line. Let me just rewrite that. Everybody makes mistakes. And sometimes if I go too fast, even I will make a mistake. So just keep that in mind. Okay, great. So now I have this right, I hope. Here's my answer. So that would be how I get to the domain. So just notice then that you have to really know this. You have to know where the expression is undefined to figure out what the domain is. And the domain is always going to be anything except for the numbers that make the expression undefined. So now, just to make sure that you've got it, here are two examples to do on your own. Just go ahead and pause the video, and when you're ready, you can hit play, and then I'll just tell you what the answers are to this. Okay, so for the first one, so all I have to worry about is where the top equals 0. So the whole expression will equal 0 when x equals 3. So I'm kind of just writing this in shorthand, just for the sake of time. Then when is the expression undefined? Well, the expression is undefined when x equals 1. So again, you're setting the top equal to 0, you're setting the bottom equal to 0, and then you solve for them, and those are your answers. So therefore, then my domain is going to be all real numbers except x equals 1. So in interval notation, if you used a number line to help you figure that out, so here's my number line here. So if I used a number line to help me figure that out, this is going to be -∞ to 1 unioned with 1 to infinity. So that would be the answer for this one. Okay, so now for the next one. So what you have to do for this one is factor the top and bottom. So just as a reference, this is going to be x plus 9 over x minus 9. And then this bottom part, this is going to be x plus 2 times x plus 3. Okay, so where does this expression equal 0? It will equal 0 when x equals -9 or when x equals +9. So one of those two values will make the whole expression equal 0. Where is this expression undefined? It's undefined when x equals -2 or when x equals -3. And then finally, what is the domain? So the domain is all real numbers except -2 and -3. And in interval notation, what that would look like is this. Okay, and so that would be it for this one. So that's all I've got for this. Just as a reminder, if you find this content helpful, please feel free to like, share, or subscribe.